Yeah, 2015, day 15. Let's take a look at what it says. Science for hungry people. Today you set out on a task of perfecting your milk dunking cookie recipe. All you have to do is find the right balance of ingredients. All right, and given the ingredients in your kitchen, what's the total score of the highest scoring cookie you can make? Okay, so now we just have to figure out how to score a cookie. Your recipe leaves room for exactly 100 teaspoons of ingredients. That's unusual. You make a list of the remaining ingredients you could use to finish the recipe and their properties: capacity, durability, flavor, texture, and calories. You can only measure ingredients in whole teaspoons amounts, and you have to be accurate. So the total score of a cookie can be found by adding up each of the properties. Negative totals become 0. Okay, that's good to know. And then multiplying together everything except calories. So I imagine calories will come in part 2. Yeah, so this is kind of important, right? Because, oh, how do you get negative? So, okay, so butterscotch has negative capacity. Durability has negative, butterscotch has negative durability, but positive flavor, texture, and calories. We don't care about calories. Although I guess we should parse it because, so how many ingredients are there? That's not a lot. So we have 4 ingredients that we're dealing with. I'll close that one. Close that one. And we just have to calculate for each ingredient, we're going to measure what? So we're just going to multiply these 4 things together, ignoring calories for now, right? It results in a total score of whatever this is, which happens to be the best score possible given these ingredients. If any properties had produced a negative total, it would instead become 0, causing the whole score to multiply to 0. Given the ingredients in your kitchen, their properties, what's the total score? Right. Okay. I'm not sure how I should begin here. Well, I begin as always by going to our mod and adding another entry in the list, which is getting quite large. I'm not sure we need any of these pub uses. I'm going to try deleting them and see what happens when I try to build. Change that to a 5, change that to a 5, and then we start a new line here, 15. Let's see what happens when I try to build. Right, so we don't have this, but we have everything else, right? Oh no, we have 16 other errors. Oh, undeclared type. So I do need that. So, oops. There it is. They don't have to be pub. Maybe that's what I'm confused by. They don't have to be pub, but they do need to be used. Oops, that was dumb. There. Otherwise, I could just put the mod in front of it, right? I could just say AOC 2015:15: this : new. That would save these lines. Okay, yeah, now we're down to 2 errors. Okay, good. And then we have AOC, expand to 2015, oops, 15. There you go. Okay. So now we should be able to run, and we should see unsolved for both answers. Good. Now the input is tiny. Let's just copy it over here. I don't know if it's worth writing a parser for this, when we could just hard code all these values, right? We have frosting, candy, butterscotch, and sugar, and we're going to multiply. Oh, got 2 of them now. You're going to multiply capacity times however many teaspoons we want of frosting, right? We're going to take the number of teaspoons we have and then just multiply those out and see what happens for these guys. And then we just calculate the capacity, durability, flavor, and texture for each one of them. I mean, that seems pretty straightforward, right? And we only have a loop. Can we just do it this way? We just do each one for frosting, candy, butterscotch, and sugar. Right? We could just do this for frosting in 0 to 100, for candy in 0 to 100, for butterscotch in 0 to 100. Actually, we could simplify this a lot, right? Well, let me just do it this way, and then we can think about how to simplify it. And then we can just say, you know, let capacity is equal to, and for frosting, it's 4. So it's basically 4 times frosting. And 0 of this, it's -1 of butterscotch. So minus butterscotch. And then 0 on sugar. So that's capacity right there, is just frosting minus butterscotch. 4 times frosting minus butterscotch. And we can do this, the same for the rest of them. Right? Let's just line these up. Like that. Yeah. And then we can look at the numbers that way. So now it's, so durability is, let's say 5 times candy minus 2 times frosting. Right? And then we have flavor. Flavor is 5 times butterscotch minus 1 times candy minus 2 times sugar. And then we have texture, which is just 2 times sugar. And then all we're trying to do is maximize this, multiply them all together. So our total score is just capacity times durability times flavor times texture. And then we can just save the maximum value. Let max equal 0. And then we just say, oh, we don't even have to do this. We can just say max is equal to max dot max of this. That's confusing. Let's call it best instead of max. Right? And then at the end, we just print out best. That doesn't, what am I missing here? One error. Oh, I'm typoed capacity. Attempt to multiply with overflow. Oh, so they're getting big. I guess we need bigger numbers. What line did that happen on? Line 35. Oh, right. I forgot. We have to have a maximum of 100. We can't go to 100 on each one of these ingredients. Oh, and the other thing was negative totals become 0. Okay, so we have to do those 2 things. So the first thing we could do is simplify sugar, right? Because sugar can be equal to 100 minus butterscotch minus candy minus frosting. Right, that simplifies that one. And then if sugar is less than 0, then continue. Right? That's all we need to do there. Will that allow us to at least run? Yeah, so now we have this number here, but that's wrong because we haven't zeroed these things out, which means doing this. Right? We want to say if it goes negative, then we want to set it to 0. But if it's positive, then we want to use the other number. So let's see what happens here. So we have a number, and it went pretty quickly, even in debug mode, because I'm thinking there's an even easier way we could do this. right? Because for candy in 0 to 100, we don't want to go all the way to 100. We want to go to 100 minus frosting, right? Because if frosting is 100, then candy has to be 0. If frosting is 50, then candy can only go up to a maximum of 50. Right? And we can do the same thing with butterscotch, and it comes up with the same number. We can do the same thing for butterscotch, right? So it's 100 minus frosting minus candy. And that reduces the amount of time even more. So I don't know if you were looking, but this was 44 milliseconds, then it went down to 29, and now it's down to 19. So we're making it faster, although, you know, in reality, it was going quickly enough anyway. So let's try this number. Let's see if it's right. It is. Yay. Okay, so that was super easy, right? This one. We didn't even have to read any data in. All we did was just calculate directly in the loop. All right, let's commit that change. (2015) day 15 part 1. Right. Okay, and then continue part 2. Your cookie recipe becomes wildly popular. Someone asks if you can make another recipe that has exactly 500 calories per cookie, so they can use it as a meal replacement. Keep the rest of your award-winning process the same. If you had selected 40 teaspoons, okay. The score would go down, but it would be the best 500 calorie score. All right, so we do need to now calculate calories. And we're already doing this in part 1. Okay, so because of this structure, these are all I32s, right? Of course, this isn't working right now. I don't know why it's being slow. Okay, so then we can just initialize these guys here. All I'm doing is going to move this into the parse function. 2, 0. Why is my... Oh, because I didn't... That's probably why this thing wasn't working. I was trying to look up the type. Yeah, there we go. I32. Okay. And then, so if we just move these lines here, all the way down to here, into parse. And then we can just save those. So instead of saying best equals 0, we just say self part 1 and self part 1. And then we want to calculate calories. Let calories is equal to, okay, let's split that screen so I can keep them both on the screen at the same time. We have 5 times frosting plus 8 times candy plus 6 times butterscotch plus sugar. And then we're going to look for an exact 500 calorie cookie. If calories is equal to 500, then all we need to do is save part 2. Set self.part2 is equal to self.part1 dot max of self part 2. Let's do it the other way around, because that way we're setting it to that. I mean, it doesn't matter effectively. It's just I'm going to keep the pattern the same. Right? Self part 1 is self part 1, the max of the new value. Self part 2 is self part 2, the max of the new value. All right. Let's see if this runs. Oh, we have to output it. Self part 1, self part 2. Okay, that's wrong. It wouldn't be the same, right? Oh, it's not self part 1. It's the self part 1 of the score. So we do need to save score after all. Or just calculate it twice. There we go. Okay, now they're different. Let's see if this works. It does. Okay. Huzzah. That was a very straightforward Advent of Code puzzle. Just coming up with this triple nested for loop, which we got down from a quadruple nested for loop. And yeah, so now all the work happens up in the parsing, and then we just print out the answers. All right, not bad. Git commit -am 2015 day 15 part 2. Good.